I believe I heard about cold fusion in March 1989 when the rest of the world did. I was attending the March meeting of the American Physical Society that was in St. Louis that year, and word came out about Pons and Fleischmann's discovery. It created quite a stir, as I think probably everyone remembers. Later, I heard about Paniff and Peter's work in 1926 in Berlin. So there actually was a even earlier report of what people might call cold fusion. I tend to refer to it as anomalous heat effect until we understand the mechanism. Very intriguing. I mean, it's a first measurement in physics. It's very important to have a lot of other groups repeat measurements and to discuss. But, certainly I was intrigued by it. I was studying superfluid helium at the time. And so it wasn't directly in my area of pursuit, but it certainly created quite a bit of excitement in 1989. I'm sure you remember.
Sure. About
Right. Well, for one, even though it appeared right off the bat from the conference, news conference, which Caltech participated in, I believe also MIT, it appeared as though there was an error made or something. And I think that was a general feeling to those like myself who were in physics but not really in this field. So I was really intrigued about, oh gosh, I guess it would have been 20 years later when I heard from people, and I'd known a few of them professionally before, like David Nagel and others, who were saying, no, there's actually something to this. And so I read into some of the papers. I asked questions of the people taking measurements. I guess what I would say is that anytime there's some controversy or interest in science, it's the scientific method that counts. It's getting the dialogue. It's getting all different thoughts and considerations uh, to design experiments that can test the things that seem controversial. And so, at any rate, I became very interested as an experimental physicist that there was this open system with the form of energy conversion I simply didn't understand. And, the question of, oh, well, is it right or wrong? Is it this or that? Again, you have to understand the scientific method. It takes a number of scientific research groups being very dispassionate and very analytic in their effects of proposing new experiments to test things. So I think it really is an exciting area of inquiry that may have been passed over for too many years since there was such a strong, unfortunate, in my opinion, emotional reaction to the whole series of events in 1989. Yeah, I was interested that very credible scientists were saying, hey, it looks like there's something there. I had a chance to see one laboratory, and definitely I saw what appeared to me to be some type of release of heat that I didn't understand. So, again, I think the value and the benefit to society of science is not reinforcing what everyone thinks, it's challenging what everyone thinks and trying to get to the point where through that challenge, again, objectively, dispassionately, we get to the point of conducting experiments that may show other things of great interest. I think it's really interesting that Konrad Zurski, from his work in Berlin as well as now Chechnya in Poland, has clearly seen some fascinating anomalous screening effects that we had not really understood at all before. And there have been similar measurements like that in Japan as well. And again, these anomalies that are fairly sizable shouldn't just be tossed away. They should be considered carefully, and the consequences to broader systems should be considered as well. Oh gosh, God, I really don't know. I mean, I think that there was probably just, people go into physics because they're not very confrontational, thank heavens. And I think this became so confrontational, a lot of physicists just like want to shy away from it. And I would do the same thing, except my curiosity leads me back to it. Oh, well, that's just how science advances. I mean, there's been, in my personal opinion, too much emphasis on theory, and there are a lot of theories. It's not that we don't have a theory of cold fusion or low energy nuclear reactions, or what I like to call it, the anomalous heat effect, until we really do understand the origin. It's not that we don't have a theory, it's that we've got a lot of theories and a lack of definitive reproducible experiments to deselect some of the theories. So the way the scientific method works is you never prove anything, you just subsequently disprove many things, and what's left standing has a high likelihood of being accurate. So, we just need, again, more experimental data that's quite reliable. That might require getting materials that are better prepared and more pure, or possibly better characterized in their impurities. And we need to get better measurement systems. So in the process of improving the measurement science, metrology, and material science, I think we'll get at enough experimental evidence to be able to start selecting or deselecting among these different ideas that are put out for theories of what might be going on. Oh, always very important. I mean, for any discipline, it's the continuous stream of great ideas that come in from the youth. I mean, look at Brian Josephson. I mean, he discovered the Josephson relations in critical phenomena. He, as an undergraduate, and then I think in his first year of graduate school, he developed the Josephson quantum tunneling and superconductors that that in a few years would win him the Nobel Prize in physics. So I mean, or he would share the Nobel Prize in physics for that development. So clearly the influx of bright young minds that are not in any sense biased by what may have been the prevalent thoughts before is a key thing to advancing any scientific discipline. Just say stay tuned. We'll find out. And everything, what will be, and what plays out, plays out. But from a immediate standpoint, I think I'd advise all scientists to not, let other people do their thinking for them, to think for themselves, to follow their curiosity, to always be self-scrutinizing. Don't publish things that are easily impeached or wrong. You want to be very careful not to increase the noise in the signal-to-noise channel on scientific publications. But with that diligence and care, to follow your curiosity and be very clear when you do experiments and publish their results.